Alright, I'm going to work through some of the problems from the survey of reactions lab that we did. And the reactions on there, it starts out, it shows sulfur plus oxygen. And you'll recall from lab that when we did this reaction, or I demonstrated that reaction, and you smelled the gas, that gas was sulfur dioxide. All right, and I mentioned that. I believe it's also in the lab guide. Okay, so there's our equation. We just need to put this into the symbolic form, where sulfur is actually not just S, but it's S8. It's a molecule, just like oxygen is not just O, it's a molecule of O2, right? 2 oxygen atoms. Well, for sulfur, it's a little bit different. There are 8 sulfur atoms, all right? So we have S8 plus O2 to produce sulfur dioxide, which, we have 2 nonmetals here. So this is a molecular compound, sulfur dioxide. All right. So I'm not going to go through the balancing. You can balance this equation. The main thing I wanted to point out here was that this is S8. Okay. And another thing is you need to specify what state these are all in. So that, the sulfur, you remember it's that yellow powder, so that's a solid compound. The oxygen, of course, is a gas, as is the sulfur dioxide. You'll recall it looked like an empty beaker, but it had that sulfur dioxide gas in it. Okay, so this relates to question number 2 on Chem 21. All right, and then moving on to question number 4, where it asks for the equation relating, or the combination of copper and sulfur. All right, this was the main reaction that we did there. And you'll recall that it formed a copper sulfide, all right? But it wasn't just any copper sulfide. It was copper 1 sulfide. You remember there are 2 possibilities for copper. It's a transition metal, so it can either be +1 or +2. It has multiple charges available to it. And you will recall that we did a test to identify which charge the copper had, and we found out that it was copper 1 sulfide. That was when we added the ammonia and it turned the solution blue. That indicated it was copper 1. It would have remained clear were it copper 2. All right, so now we need to write a balanced equation for this. So the copper metal, nothing special about any metal. They're always just the element, the metal. And then the sulfur, again, it was that S8. Just anytime you're dealing with solid sulfur, it'll be S8, right? And then copper 1 sulfide. Okay, so what this means is the copper has a +1 charge. So we have to write a formula for this. So first, let's just identify what our cation and the anion are. The cation is a copper with a +1 charge. The metals are always positive, and the Roman numeral indicates the charge. Then the sulfide, if you look on the periodic table, you'll find that sulfide is 2 columns away from the noble gases. All right, so it wants to be like argon, and so it has to pick up 2 electrons and become a -2 charge. All right, so the compound, the formula here will be copper 2, or rather Cu2s. I have to have 2 copper atoms copper ions, because each one has a +1 charge. So I need 2 of them to get a +2 to balance out the -2 of the sulfur. Okay. And so this is going to be our basic equation. Copper plus sulfur, S8, to form Cu2S. And again, I'll let you do the balancing on that. I think that's fairly straightforward. But don't forget the states of matter. The copper is a solid. The sulfur is a solid to begin with, at least, although we did it did melt when we did the reaction, but it's talking about in the beginning it was a solid. And then the copper sulfide, you recall, that was also a solid. Remember, it looked like the original copper wire that we used, but it retained the shape, but it had different properties, but it was still a solid. Okay, and any of these compounds, they will always have a zero charge total. You know, not looking at the cation or the anion individually, but the compound as a whole will have a zero charge. And on Chem 21, you will enter in that zero charge as well. Okay. Now here we have magnesium and its reaction with oxygen. Again, this is oxygen gas, so O2, and the magnesium is a solid. And when these react, they form magnesium oxide, right? That's the only thing you can form. And magnesium has what charge? It has a positive 2 charge because it's in that second column, the alkaline earth metals. So it has to lose 2 electrons to be like the nearest noble gas. Okay, oxygen, just like sulfur, has a negative 2. It's in that same column, 2 columns away from the noble gases. Right. So the compound then is just going to be, you know, positive 2, negative 2. It balances out 1 to 1, so it'll be MgO. All right. Now, when you're entering these on Chem 21, it has a box for the coefficient, it has a box for the formula, and then you enter in the state of matter, and you enter in the charge. Okay, so the charge for the neutral compounds is always 0. State of matter, the magnesium oxide, that's the ash remaining, so that is a solid. But when you do these formulas, obviously you don't have a subscript on Chem 21, so it's just O and 2, and not a subscript, but you get the idea from it. All right, and again, you will balance this on your own. Okay, then the magnesium and nitrogen, very similar. Again, nitrogen is like oxygen, it's one of those diatomics. That is a gas. Remember, the magnesium reacts both with oxygen and nitrogen. And so this will produce, this time, not magnesium oxide, but magnesium nitride. But we have to look at the charges again, because the charge for nitrogen, it's in the third column away from the noble gases. So it has to pick up 3 electrons to be like the noble gas neon. Okay, so now we have different charges, so it's not going to balance out just Mgn. All right, so I have to look at this and say, all right, I need, and you can do the little crisscross thing, Mg3N2. That will work because I have to have 3 magnesium ions to get a positive 6 charge, and 2 nitrogen ions to get a negative 6 charge. And between those two negative 3s to get the negative 6, and the 3 positive 2s to get a positive 6, it'll balance out to 0. All right, so that's the magnesium nitride, and then you will just balance this. That one's pretty straightforward. You just need 3 magnesium over there, and then these will be 1. In Chem 21, of course, you enter in a 1, and you don't assume anything. So how it would look on Chem 21, you're putting in those charges, 0 charges, even though we don't normally write the ones or those zero charges. When you put this in on Chem 21, you'll have to do that. And again, this is a solid, just like the magnesium oxide was a solid. This was the white one, that's the black one. All right, then we have cellulose and oxygen. This was the reaction of the wood with oxygen, burning the wood. Okay, here we have, and it gives you the formula for the cellulose, which is C6H10O5. I think the formula that I told you was slightly different. I had another water molecule attached to it. This would actually be the correct one. That was my mistake. Not that it really matters, because this part is given to you in the problem. And so this is O2, again, the oxygen. The cellulose is the wood. It is a solid. The oxygen is a gas. And the products, and it again helps you out a little bit. It tells you, I think, one of these is water. Okay, but there's another one, and that is carbon dioxide. All right, but this isn't liquid water. When you burn wood, it doesn't get wet. All right, this is water vapor. Okay, so make sure you get that state of matter correct. All right, again, you can balance that. You balance the hydrogen, balance the oxygen, or rather the carbon, and then balance the oxygen. Okay, don't forget you have oxygen in both of these. All right, and then lastly, one more here, the ethanol, which its formula is also given to you, and it gives it as C2H6O. More often we write that C2H5OH, but it's the same thing, plus oxygen. Okay, now the ethanol, this was a liquid.